Hello dear students. So in this video we will be discussing about some numericals on a method of section, and in my earlier video I have uploaded the concepts and some important numericals on method of sections. Okay, so this is the question: find the member forces in the member marked A, B and C for the truss as shown. So this is A, this is the member, this is B member, this is C member. Okay, so we need to find the forces in A, B and C members. Okay, so this is the truss and this is a hinge support here, this is a roller support here, 3 meter distance in y direction, and this is 3 meter distance of each joint. So this joint is having this distance of this joint is 3 meter, 3 meter, so total is 18 meter, and external load is acting on the pin jointed joints, that is 5 kilonewton, 10, 10, 10 or 5, and 5 kilonewton in horizontal direction at this joint. Okay, so before going to start, I would like to share you the concept of zero force members. So as you can easily see here, as this is your joint, and at this joint we are not having any external support reaction and we are not having any external load. So by convention, this member and this member is collinear and this is our non-collinear member. So the non-collinear member will carry zero force. So the member A carry zero force. Okay, so now we need to find the forces in B and C. Okay, so for that we need to cut our whole truss in such a way that the members which are required to determine are uh, to be considered. Okay, so I'm considering this x-axis section. Okay, so this is my x-axis section, and here the member C is considered here, and another section is y section in such a way that the member B is also considered here. Okay, so for that we need to find the support reactions first. So H is equal to, as this is a hinge support, we are having two reactions, one vertical, one is horizontal. So H 5 kilonewton is acting here, and H is equal to 5 kilonewton by summation of Fx is equal to 0. So R1 plus R2 is equal to 10 plus 10 plus 10 plus 5 plus 5 is 40 kilonewton. So R1 plus R2 is equal to 40 kilonewton. Now if I'm taking about moment about joint 1, this is my hinge support, and I know the moment at this hinge support is 0, summation of all the moment is 0. So R2 into perpendicular distance is 18, so R2 into 18 minus 5 into 3 distance. Okay, so minus 10 into 6 minus 10 into 9 minus 10 into 12 minus 5 into 15. Okay, so by this way you can write your equation, and R2 value will be 20.833 kilonewton. By from this equation, R1 plus R2 is equal to 40 kilonewton. R1 value will be 19.1667 kilonewton. Okay, so our horizontal reaction and our vertical reactions are calculated now. Now section x-axis shown in above, shown above. Okay, so this is our x-axis section, and here our free body diagram of left free body diagram, okay, of the truss. So this is our joint 1, this is a horizontal reaction R1, joint 12 here, this is a joint 12, joint 12 here, and this is our this joint 5 kilonewton, 5 kilonewton. Okay, and this is a C joint, and this is your 10 kilonewton, not 4 kilonewton, this is 10 kilonewton, and this is a third joint here, and we need to find the member forces in FC. So FC here, and this is my vertical member here, and this is my inclined member here, and if I draw this whole diagram by making the dash lines, so it is like this. Okay, so this is a 3 meter distance, and now considering the equilibrium of left hand portion, this is a left hand portion of a section XX, and taking moment about joint 11. Okay, so by this joint, as all we all know that the trusses are having pin joints, so all the moments value as pin joint is equal to 0. So this is again our pin joint, or so at this 11 joint, uh, taking moment. So FC, this is our FC member, perpendicular distance is 3, so FC into 3, okay, plus 5 into 3 distance, so this is our 3 So 5 into 3, FC into 3 and 5 into 3. Okay, and this is my horizontal part minus 5 into 3 here. Okay, so and R1, this is my R1 value into 3 and 3 6, R1 into 6. So by considering this R1 force, by considering this 5 kilonewton, 5 kilonewton and FC. So all the parts, all the forces are to be considered for taking moment about joint 11. Okay. So by taking the values, okay, so this is your clockwise and this is again your 5 kilonewton is clockwise. This is R1 is also clockwise and this 5 kilonewton is anti-clockwise. So that's why this is equal to the right side portion. So it is 5 into 3 distance. So by this way, FC value will be your minus 115 upon 3 is minus 38.33 kilonewton. Okay, so minus means it is in compression in nature. Okay, so Fa is equal to 0 due to equation of joint 10. We already discussed this is our joint 10 and we are not having any external support reaction or we are not having any external load at this joint. So our member A will carry 0 force because this member and this member are collinear and this is a non-collinear member. So non-collinear member will carry 0 force by definition or by convention. So F is equal to 0 and Fc is equal to minus 38.33 kilonewton. Okay. Now if I am considering our section YY, okay, this is our section YY and we draw the free body diagram of right hand side portion. So this is our section YY and this is our Fc value and this is our Fb value. Okay. So this is our inclined portion and we need to find the force in this member. So this is our FB value and making an angle theta. Okay, and this is a A member which is having 0 force and this is all the right side portion in the same manner which is given in the question, 10 10 5 10 10 5 kilonewton. Okay, and now theta is equal to 45 degree. As we know, all this is a right angle triangle, so this is a 90 degree, this is 40, this is our 90 degree here, this is 45 degree, 45 degree, so theta is equal to 45 degree as our all our distances are equal, 3 meters. So theta is equal to 45. So now considering the vertical equilibrium of RHS of section YY, now if I am considering the vertical summation of Fy is equal to 0. Okay, so for summation of Fy is equal to 0 means all the vertical reactions, so the Fb component, so we dissolve into two components, Fb cos theta and Fb sin theta. Okay, so FB cos theta is in y direction and FB sin theta is in x direction. Okay, so FB cos 45 degree plus 10 kilonewton plus 10 kilonewton plus 5 kilonewton, and this is your R2 value minus R2 value is equal to 0. So R2 value will be on right side here. So FB cos 45 plus 10 plus 10 plus 5 is equal to R2. R2 value we know the value of R2 is 20.833 and FB upon root 2 value. So FB is equal to minus 5.8926 kilonewton. So minus sign indicating it is in compression in nature. So therefore we are having a force in member B that is 5.89 compression kilonewtons. Okay, so we have calculated our forces in member A that is 0 and member B that is 5.8926 and that is in member C is 38.33 kilonewton in compression both. Okay, so by this way you can apply the concepts of method of section for this whole truss. Okay, if you need to find the forces in few members, then you apply the method of section only. Okay, so move on to the next question and this is the last question. So find the forces in members DF and EF for the truss. So this is our DF and EF. Okay, so I'm making a cut here, EF and DF both are considered here. So this is our 3 meter distance. Okay, this is a 3 meter distance and this is a 4 meter distance. Okay, 4 meter, 4 meter, and this is the external load is acting at this joint 10 kilonewton. Hinge support is having two reactions, horizontal and vertical. This is our hinge support again, horizontal and vertical here. Okay, so this is a 10 kilonewton. So uh, by ds value you know, m plus re minus 2j, so it is 0, so it is determinate truss. Okay, so the determinate truss and now we need to find the horizontal reactions and vertical reactions. Okay, so 10 kilonewton, this is in left to right, and this is our HA. So HA plus HI plus 10 is equal to 0. So HA plus HI is equal to minus 10 kilonewton. Okay. Now if I am considering our vertical summation of Fy is equal to 0, this means Ra plus Ri is equal to 0, as we don't have any vertical external load. Okay. So Ra plus Ri is equal to 0. Now taking moment about this hinge support, summation of mi is equal to 0. So by taking Ra into 4 plus 4 plus 4 plus 4 is 16. So Ra into 16. Okay. So Ra into 16, and this is a clockwise. Okay. And plus 10 into 3 plus 3 is 6. So plus 10 into 6 is equal to 0. Okay. So this is our clockwise. This is our clockwise about this uh, hinge support I. So clockwise moment I'm considering here plus positive. So Ra into 16 plus 10 into 6 is equal to 0. Ra means minus 3.75 kilonewton. Okay, so in downward direction. Okay, so as we have considered the Ra is equal to in upward direction, or value is in minus, so it is indicating it is in downward direction. Okay, now Ra value will be your upward 3.75 kilonewton, because we are having the equation Ha plus, sorry, this is Ra plus Ra is equal to 0. So Ri is equal to plus 3.75 kilonewton in upward direction. Okay. Now also from summation of moment at F is equal to 0 from left. So this is as we know in the trusses all the joints are pin jointed. So the summation of moment at this F joint is also 0. Now considering from left Ra into 8. So this is our Ra value. Ra into 4 plus 4 is 8. So Ra into 8 minus HA into 6 minus HA. This is our horizontal quotient and it is an anti-clockwise. So this is RA is clockwise about this joint F, and HA is anti-clockwise about the joint F. So minus HA into 6 is equal to 0. So RA value we know. So HA value will be minus 5 kilonewton. So minus 5 means we are considering this HA value in from left to right, and HI is left to right, and our result will be minus. So it is acting in this direction from right to left. Okay, that's why I'm showing here the arrow from right to left here, and HI is also from right to left. Okay, now consider a section XX as shown in figure. So this is our section XX, and we need now consider equilibrium of left portion of the truss. This is our 3.75 in downward direction. This is our HA 5 kilonewton here. This is 10 kilonewton ABD. Okay, so this is our angle theta. Okay, as this is our I think 4 meters. So 3 meters, 3 and 3 meters. So this is our 3 meter, this is our 3 meter, and this is our 4 meter distance. Okay, so if it is angle theta, then cos theta is equal to 3 upon 5. Okay, so and sin theta is equal to 4 upon 5. Okay, P upon H is sin theta, and cos theta is equal to base upon hypotenuse. Okay, so base is your 3, so this is your 3, and hypotenuse is your 5, because we are having 3, 4, and hypotenuse is 5 meter. Okay, so sin theta and cos theta value we calculated from here, and this is our section, and this is member EF, this is member FDF. Okay, force in DF member. Now summation of Fy is equal to 0. If I am putting summation of Fy vertical position, so DF value will be resolved in two components: FDF cos theta, FDF cos theta, and FDF sin theta. Okay, so FDF cos theta plus your another vertical component is this 3.75. So this is upward, so this is negative is minus. So minus 3.75 is equal to 0. So FDF is equal to 3.75 upon cos theta, and cos theta value we already mentioned here 3 upon 5. So value is 3.5. So FDF is equal to 6.25 kilonewton. So it is plus, so it is in tension. So make sure, so write in bracket it is in tension. Now summation of Fx is equal to 0. If I put summation of Fx is equal to 0, so all the forces in x direction will be is equal to 0. So Fef plus 10 here. Okay, this is our first force, second force 10 kilonewton. Okay, and this is our third force is 5 kilonewton. Okay, so this is plus plus and this is in this direction, so it is minus 5 kilonewton. And this FDF sine theta component is also in x direction, so FDF sine theta is equal to 0. Okay, so by this way FEF value, sine theta value, we calculated 4 upon 5. So FEF is equal to minus 10 kilonewton. So minus sign indicating it is in compression. Okay, so by this way you can determine the forces in EF and forces in DF, okay, by the method of section. So DF and EF forces are calculated. Okay, so thank you so much. Okay, so I hope it is clear to all of you, and thank you.